All right, so veering back, we went ahead to chapter 7, which I think is well worth it because we always need to talk about methods. Should have talked about them in chapter 2, but that's okay. Arrays. You definitely have hit the concept of arrays before in prior programming languages, assuming that you've ever taken a prior programming class. Python called them lists. In Java, you had both arrays and array strings, that's not right, array lists. Different languages have different collection types, but they all have support for something that looks like arrays. What is an array? It's a series of elements that can be accessed by an index number or a subscript number. So you can have 3 elements in an array. You can get them sequentially with a loop, or you can pull them out individually. You can say I want element 0, 1, or 2. Zero-based indexing. So an array is a list of data items, and this is a strange way to put it. I've seen another textbook that refers to it the same way. All the data items have the same data type and the same name. Well, technically that's true, right? If you declare an array called sales and you have 20 elements in it, they all have the name sales. How are they distinguished? By their index number, by their subscript. So you could have sales 1, well, the first one would be sales subscript 0, and so on, right? So we could put in numbers there. We could access, remove numbers. They do all have to be of the same type unless you're going to do some really squirrely stuff. Let's just generally say that they all have the same type, because even if you do that squirrely stuff, forget it. They're all of the same type no matter what you do about it. So the new operator is used to create arrays. There's another way to do it as well. You can use an initializer list, which is going to look a lot like it does in C++ and Java. So an element is an object in an array. The subscript, the index, is the integer that indicates its position. The first one is position 0. The second one is subscript 1, and so on. You have to remember to start counting at 0, off by 1. So the item 1 is element 0. Item 2 is element 1. When you print the contents of an array, a non-programmer user might prefer to see things like numbers 1, 2, 3, 4, and 5 rather than 0, 1, 2, and 3. So you might add 1 to the index as you print it out, and then subtract 1 if they're, if they type in an index number. And that's up to you. The user's savvy enough to understand that, that there's an element 0, then they could, refer to that directly. So sales subscript 0 is equal to 2100. And so out in memory somewhere, since these are doubles, each one is 8 bytes. So starting at some randomly chosen memory address, the operating system dictates what memory address is allocated for that array. So what address, the first one is at position 2000. The second double is stored at position 2008. The third one is stored at 2016. They're all 8 apart because the size of a double is 8 bytes. If these had been integers, every one of them would have been at 4 bytes apart. So you want to print an element, you want to access an element, you do it the same way, same syntax. So they are objects. So every array you create is of a type called system.array, giving it special powers that you don't have in C++, where it's just a primitive data type. For example, you can ask it for its size, which you cannot do in C++, which is a real pain. So when you initialize an object, the numeric fields are set to 0. You create an array of ints or longs, it's an array of zeros. Again, that's different from C++, where if you initialize an array, you get garbage, you get random values in the elements. Here, they are helpfully initialized to 0. Character fields are also all set to 0, but that winds up being null. We call it a different thing, but it's still 0. It's an unusable character. Boolean fields are set to false. Object types, like if you declare it as a reference type, you create an array of dog objects, those will also all be null. You can provide an initializer list when you create your array. It just populates the array with the specified values. Like this. Int. Here's how you would do it normally. This is like the Java syntax, real close to the Java syntax. The C++ syntax would just move the curly braces over here. But Python took Java, not Python, C# took the Java syntax because essentially C# was Microsoft's answer to Java after a lawsuit. So you've got this. It's declaring an array of events. You've got a variable name, and then inside the initializer list contained within curly braces, not square braces like you see in Python, all the values. So this would create an array of 5 integers. So with this, you feel like using the new keyword and then giving it a series of values? I wouldn't do that. I see no reason to use that syntax when this syntax is cleaner. On the other hand, if you feel like specifying the number of values here and then with your new, and then filling them in, I guess that's valid, but I wonder what happens if we change that to 10. In C++, that's legal. It would initialize the first 5 elements of this array to those, and then the other 5 would be set to 0. Not true in this language. This language, the number of items here has to match the number of items here. So again, you're coming up with a more complex syntax to accomplish the same thing. I'm never going to do any of the other two. I'm never going to ask in an exam about doing anything like that. So if you declare size, you must list a value for each element. If you initialize an array of values, you're not required to give a size. You don't even have to use the new keyword. The power of arrays becomes apparent when you use subscripts that are variables. That's the real point of arrays, so that you can process them inside a loop. Loops and arrays go hand in hand, which is why quite often the chapters appear one after the other. The length property. Need to determine the length of the array? You access its .length property. It's a property, meaning it's not a method, meaning you don't call it with curly braces, parentheses, which is just like Java. It's a property. It's set when the array is allocated. Once you allocate an array, it is a fixed length. This creates an array of 5. In Python, you could then go in and append a 6th value if you wanted to. Nope. Python's a completely different beast. In Java, C, C++, C#, and in most languages, once you allocate an array, it is fixed to that size. You want to append a 6th item to it? Too bad. You'd have to create a brand new array, copy these 5 elements into it, and then put a new, leave enough space for the 6th element. Similarly, you cannot subtract 1 from the middle of it. We couldn't do that. If you really, 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 really wanted to do that, you would have to copy all the values from the rest of the array, and like that. And that's kind of some old school programming that nobody would ever do anymore. So we're just going to say that an array's length is immutable. If you want to create an array of a different length, you actually have to create a brand new array. So you can't append to an array, you can't insert into an array, you can't delete from the middle of an array. Doesn't mean you can't set the values and get them. You certainly can. That's the point of arrays. Why don't we give a few examples? The for each loop will step through all the elements of an array. If we create an array called pay rate, you've seen this syntax before in Java, except it looked like this. Instead of the in keyword, you had that. You've seen this syntax in Python. It looked like this, except you didn't give a type. So for every money in the pay rate list, C# came up with the for each keyword. I actually kind of like that. So for each double money in pay rate, you have to give the type. Since the array is of type double, then the temporary variable we're going to be storing the elements on has to be double. Give it a variable name. The variable name is not important. It's just whatever you refer to it in here. You can call it V, you can call it Fred, whatever, as long as you use it there. And so it pulls out every element in turn. So at the first entry into the loop, money equals 6. And when we printed it out, it would be 6. Next time it would be 7.35. And it would keep going until it hit the end of the array. And so you use for each when you want to access every element in the array. Since the iteration variable is read-only, you can access it, but you can't assign a value to it. I could not get this to work. I could not say, okay, I'm going to write that value out, and oh, by the way, I'm also going to set it equal to 77. It's a read-only variable. Now, I believe there's a way to change that. I believe you can declare it as a reference variable, and you actually can change it as you step through it. It's occurring really strongly to me that you can do that. Normally, you don't see people do that, though. If you're going to step through an array and actually change the values in the array, use an index-based, a subscript-based for loop rather than a for each loop. So let's go and make a new project so that we can just have a few examples. As usual, I can't remember where we are. Q? Q is correct? P. All right. Sorry about that. Paris. Okay, so C# Lecture P. All right, let's declare two arrays, both of them integers. Int IA1 for integer array 1 equals, and let's fill it in with some numbers, 1, 2, 3, 67, 3, whatever. It's 5 elements long. I'm going to make the second array have the same length, just for funsies. Int subscript IA2 is also going to have 5 numbers in them. Whatever. Say I decide that I don't like the first element of those being 1 and 4. Say I want to change them. IA1 subscript 0 is equal to 5, for whatever purpose. Who knows what these values represent? When we print it out, it's going to say that that element would now be 5. We have replaced that value. IA2 subscript, well, what's this value? That's going to be 4. Index 0, 1, 2, 3, 4, so we're going to say subscript 4 is equal to, 0, whatever. Change that to a 0. Let's print out the arrays. What I'm curious about is if we can print it out by its reference. Meaning, if I give it this reference, is it going to do a toString on it and print it out in a nice, friendly format, like Python will, or is it just going to print out an address, like Java? So, CW tab, quote, IA1 equals, end quote, plus IA1. And then I'm going to copy and paste that to make it say IA2. Now, user would not want a raw dump of an array like this, but for programming purposes, for debugging purposes and stuff like that, perfectly acceptable. And I better put my read key down here at the bottom, console.readline, whatever. CW tab, done, press enter. And that's what I thought. If you try to print an array out, just by doing that, you don't get anything useful. Now, there is a way to get something useful out of it, but we're not going to focus on that. We're going to focus on printing it the correct way using loops. You could use an index-based loop, in which case you'd need to know the size of the array, the length of the array, or you could use a for each loop, which is far easier to do. But index-based loops are very useful because you can sometimes you need to access more than one array at the same time. Like, what if we wanted to print these elements side by side? We wanted to print 1, 4, 2, 1, 3, 5, 67, 1, and 3 and 5. A for each loop would not be a good choice for that, because then we wouldn't have an index number. A for each loop will step through only one an array. If we were using a for each loop, we would have no way of knowing where the corresponding position of this is. And yeah, you could hack a solution to it by declaring an index counter and updating it each time. But if you're going to do that, you may as well be using an index loop to begin with. Let's comment these things out because they didn't do us a lick of good. In fact, let's delete them because it didn't do us a lick of good. All it did is print the data type. Print out the elements of IA1 with a for each. Just because this is the simplest, we're going to do it first. And then we're going to do what I said, which is print them out in pairs using an index-based loop. So for int value or element or e or whatever you want to call your variable, but it's a for each loop, so for each int space e in IA1 for every element in that array. CW tab tab. Let's just write it out. E plus a space. And we should see it say, since we've replaced the first element with a 5, it's going to say 5236073, or whatever your numbers are. And that's what we got, 5236073, or whatever your numbers are. If we try to change the value of v, right, we decide to wipe out the value for some reason, not sure why, it's going to give us an error. Why? Because it's read-only. What if we declared it as a reference int? Nope, nope, that doesn't work. I must be thinking of something else. Okay. Print out the elements of both arrays using an index-based loop. So for an index-based loop, we're not going to use for each. It's going to look a lot like our regular for loops. For int I equals 0, I like I for indexer, for the subscript. I is less than the length of the array. Since these are both of length 5, I could just hard code a 5, but that's really lame. So I'm going to ask the array for its size. IA dot, or IA1 dot length. I wonder what in the world that does. I saw something weird. Get long length. All right, but I'm not going to do that. What is a long length? 64-bit integer. You'd have to have a big array in order to need to get its size as a long. It'd have to be more than 2 billion elements long. All right, I've never done that. Okay, so dot length, it's a capital L because it's what C# calls a property. In things like Java and C++, you essentially have two data types, or array, excuse me. You have two class member types. You have variables and you have methods. C# has a third type, which is a blend of the two, called properties. And a property is something that looks like a variable, but it's implemented with methods. We'll get to that very, very soon. And then I++. Close parentheses, curly brace. Let's print them out. Side by side, maybe. CW tab tab. IA1 subscript I plus comma, quote, comma, space, end quote, plus IA2 subscript I. And we really should have used a formatted print, right, to make them look all nice and neat and make them in columns and stuff. We could change our write line to use placeholders and do that if we so chose. And there they are, right? We could even print out the index number. Let's go ahead and make this look nice. So write line is going to be in quotes, and we're going to print out index space %d, and then let's print out the value of each one. Remind me, if I want to specify the width, does the width indicator come before or after the 0? Guess I could try it through experimentation. Guess I'm not going to specify the width since I don't remember that. All right, so 0 and 1. Nope, nope, nope. What am I doing? That %d is completely not this language. That is 0. This is 1. And this is 2. So at index 0, the values are, and so after the end quote, we just need to pass in arguments to fill those in. I is our index. IA1 subscript I fills in the second placeholder. And IA subscript 2. IA2 subscript I, maybe I should have given them names that were a little bit further apart, fills in the third placeholder. And there we go. So the first position, IA1 was at 5, IA2 was 4. At the second array, it was 2 and 1. At the third array, it was 3 and 5, and so on. So these are actually what are known as parallel arrays, although we haven't defined their meaning. We don't know what it is. It's just a series of numbers. A parallel array is when you have 2 or more arrays of the same length that are thematically united by their index. For example, you could have days of the week and sales. I usually do a silly example like with children's names and favorite foods or something like that. So string foods equals, and inside the curly braces we're just going to list 3 foods. Pie, end quote, comma, ice cream, end quote, comma, and some poor kid gets carrots, end quote, end curly brace, semicolon. And now the kids. String, square brackets, kids equals, why is it underlined in console all of a sudden up here? Oh, and then it went away. All right, fine. Equals curly brace and 3 kids' names. Anu, end quote, quote, Bob, end quote, and Carol, end quote, end curly brace, semicolon. Now we could print them out with a for each, but then we wouldn't be able to say anything like Anu loves pie, and Bob loves ice cream, and Carol loves carrots. For that we need an index. So for int I equals 0, I is less than the length of one of those arrays. If you have parallel arrays, they better be of the same length, or bad things are going to happen when you try to access that element. I is less than foods dot length, capital L, semicolon, I plus plus, in parentheses. Inside our curly braces, CW tab tab, console right line, curly brace 0 in curly brace, loves to eat, curly brace 1 in curly brace, end quote, comma, foods, kids, subscript I, because it's going to be the name of the person to fill in that placeholder, comma, foods, subscript I. And when we run it, we're going to see that Anu indeed likes pie, Bob indeed likes ice cream, and Carol indeed likes carrots. And that is what we see. So I'm going to use an index-based loop to run through these things again to print out the product of them. 1 times 4 is 4, 2 times 1 is, whatever, 3 times 5. Or we could figure out the difference between them, right? The absolute value of the difference between them. That might be fun. My definition of fun is different. So for int I equals 0, semicolon, I is less than I. I'm getting really tired of those names. I feel like renaming them. Real easy to do, right? I'm just going to come up here, double click on IA1, right click, refactor, rename, and call it nums1. Don't ask me why I want to name. I just got tired of seeing IA. Apply that, IA2, refactor, rename, nums2. So one thing you can do when you're coding is you can create temporary short names, and then when it's time, you know, when you're nearing the end of the project or whatever, you can get the variables better names. Okay, so back down here. For int I equals 0, I is less than nums1 dot length, capital L. I plus plus. CW tab tab. We're going to print out three things. The first is going to be one value. The next is going to be the other value. And the third is going to be the product. No, the absolute value of the difference. So why don't we go ahead and calculate the absolute value of the difference first, right? So int diff equals math.abs parentheses nums1 subscript I minus nums2 subscript I end subscript in parentheses. Now we can write those values out. Our formatting string, forgive me, I really want to remember if you specify the width is doing placeholder number :4 or, you know, or 4 colon placeholder number. Let's find out. I think it's this way. This is not going to be our final answer. Just want to see. Yeah. Surprised it didn't left justify it. Okay, fine. So you could specify the data type after the colon, and then I guess in front of the data type you can probably specify the width of it. Or you can leave the data type off and specify the width, just like I did. Okay. All right. So the first value is the index number. The second value is going to be the value of number 1, 0 colon 4, or excuse me, 1 colon 4, because this is second place value. The third one also going to be 4 wide, and the fourth one is going to be 4 wide. So 0 colon 4, 1 colon 4, 2 colon 4, 3 colon 4. And the values we're going to print out are I, and then nums1 subscript I in subscript, nums2 subscript I in subscript, and then the difference between the two. And we could put column headers. The column headers, it would be really nice if they are the same width. So to put my column headers, I'm going to grab the first part of my right line string, and since the word index is 5 long rather than 4, I'm actually going to make the first column 5 wide. So I changed it on both formatting strings. All right, and what are we going to fill in? Well, the first one is called index, so quote index, end quote, comma. Second is called nums1. That's also 5. Okay, I'm going to wind up making them all say colon 5 rather than colon 4. The next header is called nums2, and the last one is called the diff. End parentheses, semicolon. All right, these all need to be colon 5 rather than colon 4 because nums1 and nums2 are also 5 in length. Diff is only 4, but why not make it 5 just to match the others? All right, so when it runs, it should be printing out the differences of them in a nice tabular format. Okay, I botched that. What did I do wrong? It's printing out 5 each time. Is it because of that colon? Quick way to find that out. Okay. All right. I was just an idiot and forgot that it's not colons. Wrong language. Commas. So change all those 0 5s, 1 5s, 2 5s, and 3 5s to 0, 5, 1, 5, 2, 5, and 3, 5. There we go. All right, so there's our little table. Sure, we ought to have a blank line and maybe some dashes or something to polish it off, but if we wanted them to be left justified rather than right, we'd put a minus in front of the 5s. Too bad there's not a command for centering them. I'm not going to even try to think about that. I guess I could center them if I pushed over the index and the nums and the nums and the diff. Not going to mess with it. Okay, so we've seen several different array examples. We could have a data entry loop where you ask for a value and you write it to the array, right? I think we already know how to write loops that ask for values. But why not? For int I equals 0, I is less than kids.length. We're going to ask what each kid's new favorite food is. I++, string new food, wait, we need to print a message out telling them what we want. So console.write, parentheses, quote, what does, placeholder 0, like to eat? Even more, question mark, space, end quote, in parentheses, semicolon, and after the quote before the parentheses, comma, kids subscript I. I should have left the comma right there, but had a comma there, remove that, that's just personal preference. All right, now we're going to get the input, console.readline, and then we're going to store that into the array. Foods, subscript I, equals that new food. And then we can print them out with a loop again. I'm lazy. I'm going to just scroll back up and get my former loop that prints what the kids' favorite foods are. So I'm going to come up here, grab my loop that says 0 loves to eat 1, copy that, paste it. All right, what does Anu like to eat? Bread. Bob likes to eat cereal. These kids have gotten a lot more boring in the interim. Carol likes to eat ice. There we go. Something seriously wrong with Carol. She's iron deficient or something. All right, so you can do data entry. Just like that. Typically, one of the assignments I give about arrays is doing something like filling in a month, if a month array with the names of months, and then allocating another array where you generate random numbers for the rainfall, or you have to use it to input random numbers for the rainfall, and then you calculate the average, and you calculate the lowest, and you calculate the highest. Well, we're not covering how to do the lowest and the highest in this lecture because we're wrapping it up, but we know enough to do the rest of it, and then the next assignment could be to modify it to carry on with the rest of it. Homework. Allocate an array named months. Doesn't have to be capital. Initialized to, Jan, Feb, and so on. Allocate an array of ints of the same length. Why are you doing that? Write a loop that will fill in the array of ints with random numbers between 0 and 10. And we're going to call this one named rainfall. Display the arrays as a table, months and rainfall values, and then calculate and display the average rainfall. So how do you calculate the average of a loop? Excuse me, of an array? I gave the answer away right in that stumble. For each loop's the fastest way, right? We have an array called nums1, an array of integers. You would just declare a variable to contain your total, right? So double sum1 is going to be the sum of the nums1 array. Better initialize it to 0, and since a for each loop is the simplest, shortest syntax, why don't we just use that? So for each, parentheses, int value in nums1, in parentheses, sum1 plus equals value, right? And then what's the average? The average is that sum divided by the length of the array. Double average, or average 1, is equal to sum1 divided by nums1.length. Because that's how you calculate the length of the array. The only thing you need to consider, and it's not germane to this, is that if you're calculating the sum of something and it's possible that the array might be empty of length 0, then when you divided it by 0, something bad might happen. In this case, it wouldn't crash the program, but you might not like the results anyways. It'll print out something cryptic. I didn't even print out the average, so we can't prove it that it works. I can set a breakpoint and run it. Hover my mouse over it, find out what average is at that point. Oh, one error. Not going to work. Oh, I just don't have my closing. Okay. And so oh, for Pete's sake, after it executes that line, I should have just added a print for it, right? Step over that line, and average equals 16, which sounds right. I'd have to go and look at the output to make sure. No, that's the total, that's not the average. There they are, right. The 67 is throwing it way off. So yeah, it's got a high average. Okay, enough. All right, homework makes sense. Random numbers fill in the rainfall, that way we don't have to actually make ourselves type in the numbers I like random numbers. Random data is nice. All right.